So in this video I will be discussing code forces around 965 rated for division 2. So I will be solving first three problems of this set. Let's start with problem number A. So in this question I will be given three integers x, y and k. Okay. Such that k can be at most 1000. We have to find k distinct point x1 y1 x2 y2 till xk yk such that center of all these points should be equal to x and y, which is given to you. And what is the center? The definition of center is such that x1 plus x2 plus x3 till xk divided by k should be equal to x given to you, and y1 plus y2 till yk divided by k should be equal to y given to you. So how to find this number? So you can easily follow a greedy approach to find the answer of this problem. Let me show you how. For example, you are given a x like 5, okay, and y like 7, and you are given some k. For example, let it be 9, okay. So how to find the 9? So I think so. Let me take a short number. For example, let it be 3. Okay, let it be 4. Okay, your k is equal to 4. Okay, so how to find four distinct numbers such that y1 plus y2 till y4 divided by 4 should be equal to 5, and similarly for x also. So what I have done in this problem, just greedily mark the numbers. For example, -1 plus -2 plus -3 till k minus 1. Okay, just add these numbers. And you know one thing, you need one more numbers, right? Yes, I need one more number. Let it be question mark. And you know this thing, this whole equation divided by 4 should be equal to 5, because this is for y. And similarly for 7 you can do like -1 -2 -3 plus something which you don't know divided by 4 should be equal to 7. Yes, so you can simply solve this equation and find this number and find this number. So that will be your remaining number of pair, and you got your existing pair as -1 -1 -2 -2 -3 -3. So that's how you can solve the problem number A. Let's now discuss problem number B, that is minimize equal sum subarrays. So to be truth, I just follow a, I think so, not so much intuitive approach for this problem. I just randomly tried different approaches and one of them worked. So there might be some uh, explanation for that solution, you might know, but what I have done, I just simply tried the different intuitions and one of them worked. So that's how also I solve this problem. So let me explain the problem first of all. In this problem, you are given a permutation P of length n. You have to find another permutation Q of length n that minimize the number of pair I comma j such that the, for example, let me summarize the question. You have to find another permutation Q of length n such that number of subarrays with some number of I and j such that the sum from I to j should not be equal to I to j in the another array which you formed. Okay, so how to solve this problem? You can simply swap the alternating numbers, and that's how to solve the problem. For example, the array given to me is like 1 2 3 4 5. Just swap alternating numbers. That will be 2 1. Yes. Now first of all you swap these two numbers, then swap these two numbers, then this, then this. Okay, so let me tell you the intuition which does not work in my case. For example, the first intuition which I applied is just reversing the whole array, but this will not work. But why? Because in case of odd numbers, for example, they are total odd numbers. So if you reverse the array like 4 5 4 3 2 1, in this case you can similarly see your this subarray has the same sum. Yes, it is same. And your this subarray has the same sum, your this subarray has same sum, because in this point you're making a something like palindromic string. Because you know one thing, by the sum of this should be equal to sum of this, we are not reducing I and j at any point. So what approach you can follow? You can simply swap alternating numbers. That's how we can solve this problem. Just swap alternate numbers in the array itself, and you will get your final array, and that is your final array, which will be having least number of I and j with the same subarray sum from the original permutation. Okay, so that is how you can solve problem B. Let's now discuss problem C. This is a great question, and you will love the explanation also. So the problem number is perform operation to maximize the score. So in this question, you are given an array of length n and an integer k. you're also given a binary array b of length n. Okay, so what you can do, you can perform at most k operations. Okay, what is the operation? If your b of I is 1, then you can increase your a of then you increase your a of I. Okay, for example, if b of 2 is 1, then you can increase a of 2 by 1. Okay, now what you have to do, you have to find the maximum score of the array. And what is the maximum score? A maximum score is defined as, first of all, take this equation. What this equation means? This equation simply means a of I plus median of c of I, where c of I is the array which will be there by removing a of I from the array a itself. Okay, let me repeat it again. This equation means a of I plus median of that array in which you will be removing a of I plus a of I. So maximum of all of these equations will be your final answer, and you have to perform this operation. After that you will find this median part. Okay, so you know one thing, like what is a median, so that is clear. So how to solve this problem? So to solve this problem, you can divide it in two parts. First part will you say, like, add all of the k operation in the maximum element and find the median. First operation is that add all of the k in maximum element. Okay, okay, find add k in the maximum element and find the answer. Okay, for example, what does it means? uh, Let me take this array. Okay, so it simply means, for example, you cannot increase 7 because you may mean like 7 is maximum, you will increase 7 k number of times and get your answer, but you cannot increase 7. But why? Because there is 0 over here. Okay, and you cannot increase it. This is the whole reason. So the maximum number which is having 1 in its binary representation, you can increase that number and find the maximum such number. The maximum such number is 4. Okay, and what is the k in this? The k is 4. Okay, the k is 4. So increase 4 number of times and make it equal to 8. Your final array would look like 4, 7, 2, 5 and 8. Okay, yes, this is my final array. Now find the median with respect to this element. Okay, that is 8 plus median of this array only, because in the median you will not consider this element which you have taken previously. So the median of this array would be like 2, 5, 5, 7. So the median is 5. So 8 plus 5, that is equal to 13. So one answer can be 13. So this is the one possible answer. Okay, store this 13 because you will need it in the end, because you will compare it with another answer. Okay, so first answer is 13. Let me repeat it again. You will increase your maximum number which is having one in its binary representation to k, and your median would be, your score would be maximum element plus maximum element the the element which you have increased k number of times, that number, plus median of your current element, like median of your current array after removing the maximum number. This is your first answer possible. So what is the then what is the second answer possible? Okay, let me tell you that also. In the second answer, what you will do, you will try to find the largest median possible. Okay, so what is the in this what you have done, you have just simply try to maximize this equation. For example, your equation was, what was your equation? A of I plus median of c of I. Yes, this is my original equation, right? So in this first approach, what you have done, you have maximized this a of I. Yes, I have maximized this a of I. In the second operation, what I will do, I will maximize this median part. Okay, but how to maximize this median part? To find the answer for the second part, what you will do, you will first of all find a number which can be largest median of your array after performing k operation. Let me repeat it again. In the second operation, what you will do, you will find the largest median possible, which can be your median of your final array after performing k operations. I will get back to you how to find this part. Okay, first of all, take this part. Okay, you have find the largest median possible after performing k operation. Okay, then what is the next step? Just simply add the largest number possible in the array itself, which at that point, plus median which you have found. but or I can say the median of your current array. Okay, but let me get back to you how to find the largest median possible with after k operation. Okay, let me take an example. Let it be this only. uh, okay, so this is the array given to you me. So this is the array given to me. I have to find the largest median possible with 4 operations. Okay, so what is the median? First of all, median is the n by 2th smallest number in your array. Am I right? Yes, I am right. So how to find that number? You can simply find, for example, if I sort this array would look like 2, 5, 5. Okay, here it is 4, then 5, then 5 and 7. Your you have to maximize the value at this position. Okay, after sorting the array, let me repeat again. After sorting the array, you have to maximize the number at this position. But how you can maximize? So I can simply use a binary search method to find the largest median possible. Okay, I will try to find like whether my x can be my median. If x can be my median, I will try to find with another possible number which is greater than x. Can that be my median? If that is not my median, I will try to shorten my range. Can this be my median? So similarly, this is the binary search approach which I will be following to find the largest median possible. But next question, how to check whether my current number can be largest median or not? Okay, so for this you will need k also. Yes, I need k also. So if you are having n by 2 numbers which are greater than 4, greater than equal to 4, can in that case, okay, let me begin. If you are if you're in your array, if you are having n by 2 numbers which are greater than or equal to x, can in that case your x can be median? Yes, my x can be median. For example, let it be x only. For example, in this array you are having total, for example, what is this index? This index is 0 1 to 12 index. Okay, let me, what is this number? This is third number. One which indexing, this is third number. If you're in your array, you're having total 3 numbers which are greater than or equal to x. Can be my x the median? Yes, it will be definitely be median. I don't have to think twice. For example, let it be x, let it be 5, let it be x, let it be 5 again, and x. After sorting the array, after sorting the array, my x will always be at the middle position. I know this thing. After sorting the array, my x will be at the my x will always be at the middle position. Yes, because you know one thing, x are greater than or equal to n by 2, and after the sorting the array, x will always be at the middle position. So okay, but how to check the condition? Okay, how I can check the condition? For example, in this array, I am taking the example like this: 4 5 7 2 5 4, and I am aiming. Can my let me take it. Can 7 be a median? Okay, I'm aiming for 7. I'm aiming for a 7 median. Okay, I'm aiming for a 7 median. Okay, what I will do? I'm having a 4. I'm having a k of 4. Keep these numbers with you. I'm aiming for 7 median and I'm having k is equal to 4. Okay, start iterating in this array. Okay, is your this number greater than or equal to your targeted number? Yes, it is equal to the targeted number. Done. I don't need this. Now first of all you have to sort this array also. I forgot to tell that for just forgot. Sort the array in this reverse order. 7 4 5. Okay, and what is this 2? Okay, great. Is 7 greater than or equal to your target number? Yes, it is equal to. Just increase your counter by 1 because you are having counted one number. Is your 5 greater than or equal to 7? No, it is not equal. But how many such numbers it need to become 7? That is 2. Okay, which means I will increase my this number by 2. But there is also condition. But there is also condition. My 1 should be beside 5 because that only, because in that case only I can increase my 5. Okay, let me check it here. No, there is no. What is the corresponding? This is 1, 0, 0, 1, 0, 1, and I am at this position. Can I increase my 5? I am checking. Can I increase my 5? No, I cannot increase my 5. Just increase to this next pointer. Can I increase my 5? No, I cannot increase. But can I increase my 4? Yes, I can increase my 4. Okay. So now tell me how many units just for this 4 needs to become 7? That is 3 units. which means I will utilize 3 number of operation by in increasing this 4. Okay, this will become 7 and your k is decreased to now 1 only because you have used 3 operation in increasing 4. Okay, now tell me how many numbers are there which are greater than or equal to your targeted number, that is 2, because 1 is this 7 and 1 is this 7. Now your count become equal to 2. Okay, now you are at this position, this 2. Now tell me, can you increase this 2? First of all, yes, I can increase this 2 because 1 is beside this 2. Okay, how many operations this 2 needs to become 7? That is 5 operation. But how many operation I have? I have only 1 operation left. Let it be case I am having 5 case. I am having 5 number remaining. So let it be the case I am having enough k to increase this 2 also. I am just taking a hypothetical case, but in this case you do not have. I am taking a hypothetical case. So I am increasing this 2 to 7 also. If I am increasing this 2 to 7, my number of 7 now has become 3. And is the 3 equal to n by 2? Yes. Now my total number of 7 in this array are 3. Now my final array would look like 7, 5, 2, okay, I think so. 7, 5, 5, 7, 5. So if I sort this array, after sorting the array, it will become 5, 5, 7, 7, 7. Is my 7 at the middle position? Yes, my 7 is at the middle position. But why? Because the occurrence of 7 are greater than or equal to n by 2. Okay, but this is the hypothetical case. In this case, you are only remaining with 1k. In this case, you cannot make this 2 equal to 7. Okay, I cannot make this 2 equal to 7. So my 7 cannot be median, can never be median if my k is equal to 4. Okay, that justifies the equation. Okay, so what you have to do, using these operations, just find the maximum median possible. Okay, finding the maximum median possible. After finding the maximum median, the answer is pretty much simple. Okay, what is the answer now then? For example, the maximum medium is m. Okay, let it be bigger m. For example, this is my maximum medium. Okay, after find the maximum medium, just sort the array and find the current largest element. Find the current largest element and compare it with, to whom I have to compare it with. Just remember this part. Compare it with this 13 which you have found in the operation number 1, because this is the operation 1, this you are getting by operation 2. The maximum of these two operations will be your final answer. Okay, just this is the whole solution and intuition of the problem number C. Let me show the code. You will get the code of A and B in the description. Let me explain the code of C. Okay, first of all, take the input of the array. Okay, I'm taking the array itself, and this is a binary array in the second part of my vector. This is vector pair this is the pair int comma int. First part is my array itself, second part is my string, binary string. Okay, what I am doing next, I'm checking if there is any one in your binary string, then do this. Else what you have to do, if there is no one, which means you cannot never increase your any number. In that case, answer is simple. Your maximum number plus median of your remaining elements, your median of n minus 1 elements, because your last number is largest possible, just return there. But if there is at most one, there is at least one in your binary string. In that case, what you will do, this is the first part. I am just trying to increase my largest number. Okay, see here, I'm just traversing from the last of the array, and if the b is set for that number, I will just increase that number by k. Okay, increasing that number by k. And for the median array, I'm skipping that number. You can see for the median array, I'm skipping that number, and this is the median array, and sorting the remaining array. And what I'm doing, I'm just finding the median of that array in which the largest number is not there, plus the largest number itself. This is the answer number 1. Okay, now for the answer number 2, you will run a binary search. Okay, for each and every number, this is ma'am, for each and every number, you will check whether this can be a median. If this can be median, I will just increase my range. If this cannot be my median, I will just decrease my range. Okay, okay, but after finding the median, I will make my numbers which are smaller than L to equal to L, because that's how you can get a median. And finally, the answer would be largest number plus median of your current array, median of your n minus 1 elements. Because in this median, you will be having largest median as L. Okay, And now the remaining part, how to check whether my m can be median or not. You can find it simple easily. Okay, I am just making a target because this is the number of elements which I want, which should be greater than my x. X is my targeted median. Okay, I'm just traversing from the reverse of the array, checking if my current number is greater than my targeted median, just increase the count. If at any point my count is greater than target, which means I have increased, I'm having n by 2. Now I am having great numbers which are greater than x, total count of n by 2. So just break it there. But if my current number is not greater than x and the BFI set for that number, then what I will do, I will try to find the remaining, I will try to find the numbers which is needed to make that number equal to x. Okay, and just increase the count because this is necessary. If at any point my number of operations just increases the number of k to me, just return false. Else just compare whether your count is now become greater than equal to target. Just break the loop and return this, because your x should be s should be always be smaller than k, because this is the number of operations required, and your count will be greater than equal to target because the number of such elements should be greater than n by 2. Okay, hope so the problem statement is clear to you. If you have any doubts, please do ask in comments, and please subscribe to my channel. Stay tuned for the next one. Thank you.